Welcome to the Module 14 Part 2 notes. In this section, we will look at how to perform a confidence interval for a mean. So the first thing we need to talk about is a point estimate for the population mean. The best estimate for the population mean is going to be the sample mean. So I have here information about the miles per gallon of a sample of 16 Chevy Cruzes, which by the way is what I drive. So we found 16 Chevy Cruzes and we recorded the miles per gallon from this website and reported them in the table below. So the point estimate for the average miles per gallon of all Chevy Cruzes is going to be the sample mean for these 16 Chevy Cruzes. So X bar. You can calculate this by hand by adding all the values together and then dividing by 16, or you can do it in your calculator using the 1var stat function. When you do this, if you have a calculator like the one I use in the video where it shows you a menu, you need to make sure to clear out that frequency list option. Otherwise, just make sure that you tell your calculator where to look for the data, either list 1, list 2, whatever it may be. And when you do that, you should get a sample mean of 36.8 for these 16 Chevy Cruzes. So we're going to use this and build our confidence interval around it, just like we did with proportions. So the equation for a confidence interval of a mean is the sample mean plus and minus a t alpha over 2 times the standard deviation for the sample divided by the square root of the sample size. So we're still having to use that t distribution because we're using the sample standard deviation and not the population standard deviation. So we don't have the information about the population, so we have to use the best guesses, which are X bar for the sample mean and S for the sample standard deviation. So let's go ahead and construct a confidence interval for all of these. Okay, now the first thing we need to do is we need to verify normality because it needs to be normally distributed. Now here we run into a problem. It does not say anywhere that gas mileage is normally distributed, and I only took a sample of 16 cars. So right here, I would stop and I would say, oop, it's not normal. We're not going to continue on. However, I am going to continue on because you need to see how to do this confidence interval. Okay, so we're just going to assume gas mileage is normal. Just for this example. And if you see anything in your discussion posts like this, but you shouldn't. I do a much better job with my discussion posts. All right, so verify it's normal, which we're going to pretend it is normal. Second step is to, that's not the color I wanted. There we go. Second step is to find X bar and S. So we already found X bar. That is 36.8. And then we also need to find S, which is the sample standard deviation, which is 2.9171. Okay. Now, step 3, let me get rid of this mark. Step 3, we're going to find T alpha over 2. So we're going to find the T score. And for that, we're actually not going to use our calculators because if you have ATI 83, unfortunately your calculator is not able to do this. So instead, we have a table that I have uploaded, and I'm going to jump to that table right now. Back right here, we have a table. This is our t-table. Let me zoom in a little bit. I can't turn the screen so it's a little bigger because it'll stop recording. Okay. Our t-table gives us some information. So the top is the cumulative probabilities, followed by a row if you're doing a one-tailed test, and a row if you're doing a two-tailed test. We don't need to worry about any of those because we don't need to find a t-value when we're doing our hypothesis tests except for the t-data, the test statistic. These values would be used if we were doing the other method of hypothesis testing. And then notice the first column is the DF, which stands for degrees of freedom. So we're going to have to remember what that is as well. And then this bottom row says confidence level, and we've got some percentages. 0, 50, 60, 70, 80, 90, 95, 98, 99, 99.8, 99.9. So we're going to use the degrees of freedom and the confidence level on the bottom to find the t-value that we're going to use in our interval. And this is the same idea as it was for proportions. Okay, we're looking for the middle 95%. So what's the positive and negative t-value on either side of the mean so that the area in between is 95%. So what I'm going to do is I'm going to start marking things up. So this example, we're doing a 95% confidence interval. So I'm going to start by looking at my 95% column. And then our degrees of freedom. Remember, degrees of freedom, let's try that again. Degrees of freedom is equal to n minus 1. So we surveyed 16 Chevy Cruzes, so 16 minus 1 is 15. So 15 and 95, I'm just going to find where these two meet. So come across until I'm at the 95%, and they meet at 2.131. And this is how you find the T alpha over 2 for your confidence interval. Now notice, looking a little bit further down at this table, once I get to a sample size of 30, it goes by 10s and then 20s and then even more than that. So if you have a degrees of freedom that does not show up on this table exactly, okay, so let's say I took a survey of 500 people. Well, 500 minus 1 is 499. This table does not contain the value for 499, so I would round down, always down, to the closest degrees of freedom that the table contains. So if I'm taking a sample of 500 people, rounding down, the closest degrees of freedom would be 100. And the reason for that is we don't want to restrict the area in the tails. If anything, we want to allow for more area in the tails with those T curves. So we're going to round down to whatever the closest value is in the t-table. But for our problem, we didn't have to do that. So we have a t-value of 2.131. So I'm going to go ahead and come back, and I'm going to write that down. 2.131. I'm going to not forget it. I probably will. All right, t equals 2.131. And now I have all the information I need, so I can plug everything in. Plug it in, plug it in. Sorry. Anyone remember that old What Febreze commercial or something? Yeah. So we're going to plug everything in. So our x bar was 36.8 plus and minus. Again, we're going to do this equation twice. Our t is 2.131. Our standard deviation is 2.9171 divided by the square root of our sample size, which is 16. All right, and I did not calculate these ahead of time, so let's go ahead and do that. 36.8 minus 2.131 times 2.9171 divided by, I know the square root of 16 is 4, so I'm just going to divide it by 4. All right, so we get 35.2459 and do it again. But now we're going to add instead of subtract. I don't know where my cursor is. Okay, plus, oops, plus, okay, here we go. And 38.3541. All right. And again, just as before, this second piece here, oh no, y'all can't see it anymore. Why? Oh, come on. That's really depressing. All right. This was divided by the square root of 16. 2.131 plus minus 36.8, 38.3541. All right, and again, this second half, the 2.131 times the standard error is called our margin of error. All right, and the very last thing I'm going to do is I'm going to write out an interpretation. It's going to be very similar to the interpretations for proportions. So we are 95% confident that the mean gas mileage of all Chevy Cruzes is between 35.2459 and 38.3541 miles per gallon. I kind of cheated and I used my answer as part of that. Why did it not save? Oh my goodness gracious, y'all. Okay, try this again. There we go. All right. So we are 95% confident that the mean gas mileage of a Chevy Cruze is between 35.2459 miles per gallon and 38.3541 miles per gallon. So that means 95% of the samples that we could have taken would have had a mean between 35.2 and 38.4. Or 95% of all Chevy Cruzes will have... No, that's not true. Ignore what I just said. 95% of all possible samples are between 35.2 and 38.4. That is correct. And I am 95% confident that the mean gas mileage is between these two numbers. All right, so let's go ahead and do one more. We'll do a 99% confidence interval for the same information. So again, step 1 will be to verify normality. I have a lot more room for this one. And again, we're just going to assume it's normal so that we can do the example. If this were to actually happen to you in a discussion board or classwork, you would just tell me, hey, this isn't normal. I'm going to stop here. If this somehow happens to you in an online homework, I would say keep going. Otherwise, you're not going to get full credit. Because the online homework may not always want you to verify normality. Okay, step 2. I don't remember what step 2 was. Find X bar and S. Oops, I'm using blue this time. So we have the same mean and the same standard deviation because we're looking at the same data. I don't remember what it was, 2.9171. All right, step 3. Find our t. So we're going to have to go back to that table. So let's go ahead and go back to the table. So now we still have a degrees of freedom of 15, but now we're doing a different percent confidence. This time we're looking at 99% confidence. So I'm going to come up this 99% until I find 15 for the degrees of freedom. And I wrote over it so I can't actually see what that number was. 2.947. 2.947. So my t value is going to be 2.947. Okay. All right, step 4. That's a very different 4 than I've ever written. Plug everything into our equation. So again, everything's going to stay the same except for now the t value is different because we're looking at being 99%, the middle 99%, so we're further away from the mean, which is why we're able to be more confident. So 30, oh my goodness, I don't know why my pen is not writing very well today, guys. 36.8 plus and minus 2.947 times 2.9171 divided by the square root of 16. Ooh. All right, so go ahead and calculate that. 947. Do, 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 do. 947. Okay, there's 1. And then do it again, but with the other sign. I apologize for this downtime. Hopefully you're calculating as well and not just staring at your computer waiting for me to give you the answers. Minus, okay, here we go. So now I get 34.6508 and 38.9492. All right, and my last step, I'm going to write my interpretation for this interval. So again, this is something I could give my grandmother, and she would understand what we were trying to do. Okay, so we are 99% confident that the mean gas mileage of Chevy Cruze, it's not how you spell Cruze, is between 34.6508 and 38.9492 miles per gallon. All right, so this is how you do a confidence interval for a mean. Biggest differences is we're using that t-table now to find that t alpha value. Okay, otherwise verify normality. Find the sample mean and the sample standard deviation. Some problems will just give it to you. Some problems like this one will not. Find the t-value using the table. You will be allowed to bring a table in with you for your exam. I may also just provide it for you on the exam. Okay, so for your final, you will be allowed to use the t-table. And then step 4, plug everything into the to the confidence interval equation. And then finally write an interpretation, something that your grandmother could understand. You can use this interpretation as a template. So that is it for confidence intervals for means.